Hi, hello, how are you? Craig Chapman here for Embarcadero Technologies, and today we're going to be looking at building REST-based applications using RAD Server and RAD Studio. My email address and Twitter handle are on the screen, so feel free to get in touch if you have questions. Let's take a look at what we'll be discussing today. First up, I'm going to introduce REST, what REST is and why you should consider using REST to design your applications. And then I'll discuss some of the common practices in building REST applications that have become something of a de facto standard. We'll then open up the IDE and begin building a REST service with RAD Server, and we'll follow that by building an application to consume that service. So let's get started. What is REST? The word REST is an abbreviation of the phrase representational state transfer. It's an architectural design style introduced in a 2000 dissertation by Roy Fielding. Roy is the co-founder of the Apache HTTP server project and was responsible for designing the HTTP protocol version 1.1. In fact, the HTTP protocol was designed using REST as the design style. Now, REST is not a standard or a protocol, it's a style for architecting an application, and in that way it's somewhat loose. But Roy's dissertation discusses several constraints which should be applied to your application design in order for it to be considered RESTful. So today, in the interest of brevity, we're going to discuss 4 of these constraints and how they apply to your applications. Again, for brevity, the first 2 constraints I'm going to group into one. In order to be RESTful, an application should be a client-server-based application and services should be layered. This essentially means that REST is a SOA-based architectural style, so a service-oriented architecture style, in which the client portion of the application consumes one or more services, which may be grouped by functionality into layers. In the demonstration today, we'll build just one service, so we'll have just one layer. Our next constraint is that communication between the client and the server should be stateless. This, of course, does not mean that your application has no state, but rather the server should not be responsible for the state of the client. For example, if the client part of your application is reading data from the server in pages, the server is not responsible for remembering which page of data the client just read and which one it needs to read next. The client maintains its own state in that regard. In a REST application, the server is considered to be a state machine, in which the data itself is the state. So the client application can alter the state of the server by transferring state changes to it in the form of new data representations, hence the name representational state transfer. We'll discuss this in a little bit more detail later. The final constraint that we'll consider today is that a RESTful application should have a uniform interface. This is often the difficult part for someone new to REST to understand, particularly for engineers familiar with object-oriented programming. Typically, in other client-server-based architectures, resources on the server are considered to be objects, with methods and remote procedure calls to be made to manipulate those objects. For example, in a library application, you might call one method named getBooks to retrieve a list of books that are available for loan, and then you'd call another method getMembers to retrieve a list of library members that can borrow those books. In a REST application, objects on the server are called resources, and they're considered to be representations of state, so part of the state of the server. A select few methods are used to manipulate these resources through state changes. So if you consider the well-known CRUD, in which you have only 4 methods, create, read, update, and delete. These 4 methods are reused across all types of objects. So you can create books, read books, update books, delete books. And similarly, you can create, read, update, and delete members. And this works for any other kind of object. This is reflected in the way that HTTP functions with its 6 methods, get, post, put, delete, options, and head. And we'll see this again as we look at some of the more common practices in REST applications. For now, let's take a minute to talk about why you might want to use REST for the architectural style of your own application. As we've discussed already, REST imposes a uniform interface on communication between the components of your application. This means that it's possible to split up the development of an application among several developers or teams. REST is also ubiquitous. Many major organizations are using REST to provide online APIs and data resources. Most programming languages and development environments have strong support for REST-based applications already. REST application resources are also discoverable, so that any client that conforms to the application interface needs little more than a single resource locator, a single URL, to discover the available data and services on a particular server. Due to the stateless nature of REST applications, they are also resilient to unstable connectivity situations, such as running an application on a cell phone or a tablet where network connectivity may not be consistent. And REST applications scale. If you need proof of this, just look at the entire World Wide Web. It's basically one giant REST application. Scalability doesn't get much better than that. So, as I mentioned earlier, REST is not a standard or a protocol. Having chosen to use REST for your application, how can you be sure that the data and services of your APIs can be consumed by third-party applications? Just what are the common practices and standards used in most REST applications? Well, while these are not requirements imposed by REST, there are several common practices used when building REST-based applications. First of all, REST applications typically use HTTP as their transport protocol. Being RESTful itself, HTTP lends itself to building REST services. So common is this practice that the term web service is now almost synonymous with REST service. Using HTTP also means that your REST services can make use of uniform resource locators, or URLs. Often a piece of data is identified on a REST server by a URL with an item name or number appended. The HTTP methods post, get, put, and delete are typically translated as create, read, update, and delete respectively, which offers the uniform interface that's required as part of a REST application as the well-understood CRUD pattern. In order to transfer data to and from a REST service, JSON is typically used as the transfer encoding. JSON, being born out of JavaScript, is a human-readable data encoding. It makes it easier to work with for debugging purposes, and it's understood by just about every web browser. For this reason, most programming languages also have facilities for encoding and decoding the JSON format. So this makes JSON a great candidate for transferring data objects or representations between the client and server application. So with this understanding, let's get started and build a REST service. Okay, so here I am in the RAD Studio IDE, and I have my RAD server installed and configured, and we're ready to start looking at how to build SOAP services using RAD Studio. Now, I have this pre-made source code package here, which you'll be able to download from either the link in the video description or the accompanying blog post, and it contains both Delphi and C++ Builder source code for both the server and the client component that we're going to take a look at. Before we do get started looking at the source code, however, I'm going to show you how to build the server-side package for RAD server. Now, before I do that, I'd like to clarify a little bit more terminology. So as far as RAD server is concerned, a resource is actually a collection. So I'm going to be looking at the employees database that comes with Interbase as part of the RAD Studio install, and it contains a table called employees. Now that whole table, of course, is a collection of records, collection of employee records. And so we're going to expose that as a resource called employees. That's a collection. If we wanted to look at an individual employee record, we can specify it by adding the record ID on the end of the URL. When we do this, we're referring to a specific item within that resource. And then finally, we've got the endpoint, get, post, put, and delete, the HTTP methods. These are essentially called endpoints in RAD server. Now, the reason I point this out is that other programming languages and other tools do things differently, so you may find documentation online which differs from this terminology, but this is the way that it's done in RAD server. So let's get started by creating a new project. So I'm going to go File, New, Other, and I'm going to select Delphi project because we're building the Delphi module here, and I want to build RAD server, and I want to build a RAD server package. So I'm going to go ahead and select that, and I'll get the package creation wizard. Now the first page of the wizard asks, do I want to create an empty package that I can add resources to later, or do I want a package with an existing resource already in it? Now if I choose the second option, the IDE is going to do a little of the work for me and build a template resource. So I'm going to go ahead and select that. Now the resource name, as I said, this is the collection name. This would be employees. And then I need to select, do I want a data module or a unit? Well, if I select a data module, I'll be able to drag and drop FireDAC controls, FireDAC components onto a visible design layout, which is the data module. If I select a unit, then I have to instance those classes in the code at runtime. I'd like to do this at design time, so I'm going to leave that as a data module. Now at this point, I could click finish and I would be done, However, it would only put in 2 of the HTTP methods. So let's go and take a look by clicking next at what we can select here. We can have the get method, the post method, the put method, and the delete method. Now you'll notice that get is actually there in 2 forms. The first is to get the entire collection, and the second is get item, to get a single item from the collection. Similarly, the put method is only available as a put item. In other words, we're only going to be able to update 1 item at a time in this call. And the reason is that this is using the URL again to specify the item number. So we get a single method to update the specified item. And the same is true for the delete method. We are going to specify on the URL which item we'd like to delete. So that's the methods that we can select. I'm going to make sure they're all selected and click on finish, and the IDE will generate a project for us. Now, if I go and take a look at the code behind this module, you'll see that we have our methods get item, post, put item, and delete item. And all of these methods have the same prototype essentially. They are all procedures, and we have a context, a request, and a response object as parameters. Now, the reason why they have these 3 is that the request is going to carry up all of the data from the client request. The response is where we're going to send the data back to the client, and the context is essentially a class that binds the request and the response with some authentication information. We're not going to be looking at the context in detail today, we're just going to be using the request and response. Now if we go and take a look at the get item method, again you'll see it's the same prototype of parameters. So where do we get the item from? Well, we have these attributes. If you look above the class, we have the resource name called employees, and we have the resource suffix item. And what this is telling the compiler is this first piece right here, this is the first URL segment after the address of the HTTP server, the web server. So whatever our URL is, /employees, that's where we're going to get the employees resource from. The very next segment on that URL is the item, and it differs in that it is not specified as item, as a piece of text, but rather as a parameter. And so you can see that we have these little curly braces either end of the parameters to say that this is a parameter and not just part of the URL. So if we go and take a look at the default generated get item method, what you'll see is that it's essentially going to get that item as a parameter from the request class, and then we're going to send a response in the response class by setting, as a component of the body of the response, a value will be set to a JSON string, and that string is just going to contain the word employees, and then we're adding on the item ID that we found. Now that means that when we call this method, all we should see is, let's say we ask for employee number 5, we'll see employees 5. And then on the end of that, we've got this Boolean property here, true, false. Essentially, you're always going to want to set this true. What it's saying is the object that we've passed in here, this tJSON string, is owned by the response. And that means that the response is responsible for releasing that object. Now, the reason why you want the response to release it is if we release the object ourselves, when we get to the end of this method, the response will be sent, but the response class may depend on that class that we passed in, and if we freed it ourselves, it's no longer available. So we just let the response take care of disposing of that class. The get method is of course more simple. It simply outputs the string employees. There is no item number for it to forward out, and so that's what it's going to send to us. I'm going to go ahead and run this module. Okay, and what happens is we get the EMS development server. So this is part of the RAD server package. And so what this is, we are developing a server module to be plugged into either Microsoft's IIS or the Apache web server. And because we might not have IIS or Apache installed on the development machine, this is a kind of a stand-in HTTP server. So this is taking the place of our web server for us, and it's already configured to host the package that we're building. So let's go ahead and open a browser window. And the default for opening a browser window, the default URL, brings us to localhost on port 8080 /version. So version is a resource that gives us the version string of the EMS or RAD server. Now there are a couple of other pre-existing resources, but the one we're interested in here is employees. So let's go take a look at that. And as you can see, it forwards out the string employees. And if I specify an employee ID, let's say number 5, then I'll get employees 5. And I can put anything I like really on the end of here, employees A and so on. So this could be a UID or an integer index or whatever it might be that you want to use as your item identifier. So with that working, let's go ahead and good. So this is an error message you may come across from time to time when you close down the development server. It's nothing to worry about. Effectively, the exception is being trapped internally within the Indy component set, but the IDE is trapping it for us. You can set the IDE to ignore this. It won't affect development. So I'm going to go ahead and break out of the code here and stop. Okay, so let's go ahead and take a look at the server that I built. Okay, so in the RAD server D package, which is my Delphi source code here, I'm going to go ahead and open up the main module main, and we'll take a look. I've installed 2 components on this module. These components are the connection to the database and the query that we're executing. And the way that I installed those is really very simple. I just come over to the Data Explorer tab here, under Interbase, Employee for the employees database, Tables, Employee, and I can drag that table on to my module. Now that would drag both the connection and the table, and I've then renamed them to con and QRY for query. So I have a connection to my Interbase database set up there. Let's take a look at the methods. So the methods that we have here are get item, post, put item, and delete item, the same methods that we were looking at before. Let's take a look first at my get method. What I'm doing in here is I'm opening up my query, which is connected to the employee table, making sure that it's active, making sure there are more than 0 records, and then I'm going to create a JSON array. Now this JSON array is going to contain the results that I'll send back. Then I'm going to step to the first record in the query, and while not end of file, so I'm going to loop through every record in this query, I'm going to create a new object, one object to represent each new record, and then each field in that record I'm adding to the object with both its name and value. Then I'm adding that object to the array that I created, and then skipping on to the next record. Once we've looped through all of the records, we'll come out here where I set the response class, so that's our response parameter. The body of it is being set to the value A, which is our JSON array, and I'm setting true to say that that array is owned by the response. So effectively here I'm just doing a select all from the table and copying the data from the fields into a JSON packet to send back. Now before we look at that working, I'm going to go down and look at the get item method here. This is doing effectively the same thing, but in this case there's no array. Because I'm requesting a single record, I'm just going to create that one JSON object, and what I return from the request is the same JSON object. And again, because I'm specifying a single item, what I'm going to do is I'm going to get the item from the URL that we're passing in, and that item is a numeric value, but it's being passed as a string, so I'm doing a string to int conversion here, and I'm recording that as the employee number, so I'm getting the number of the item that we care about. I'm then altering the SQL of the query that I'm executing, so it still selects star from employee, but I'm adding the where clause of employee number equals, and I parameterized the employee number, and then that parameter is being set to the employee number. So when I activate this query, I should effectively only have one record, and that record will be the record that I've requested. If I have 0 records, then this condition is going to fail right here, and the method will return without anything in the body. So same thing, I'm just not building an array, I'm sending back a single record which I've requested by employee number. So let's go ahead and run this server and see that method function. So here I am in the EMS development server, and I'm going to open up my REST debugger, and what I need is the address of the server, which is localhost on port 8080, And then in parameters, I'm going to specify the resource that I'm interested in. And then I'm going to come back to the request tab, and we're looking at the get request. Now, if you remember our HTTP to CRUD conversion, get is read. So let's go ahead and send that request in. Resource not found employee. Okay, so I put the wrong parameter in here. Should have been employees because this is a collection. Okay, so let's run that request. And what we get back in the body here is all of the employee records from that employee data table, encoded as JSON data. Okay, let's suppose I want to pick a single employee out of this list. Let's go for employee number 4. Well, all I'm going to do for that is extend my URL. So I'm going to put /4 on the end of the URL and run the request again. This time I get just employee number 4. That's all of the data that I have. So that's how I can select data from my database. Now let's go and take a look at some of the other methods. So I've got here the post method. Again, from HTTP to CRUD, post is actually a create statement. So I can use this to create a new entry in the employees database. And the way that I do that is this. First, I'm getting the body of the request. So the body of the request is going to be a JSON packet, a JSON object, which represents the record that I want to create. I'm then going to build a SQL statement to insert into the employee table all of the fields that I care about right here, and then I'm parameterizing each of them. So I'm then going to set as parameters each one of those fields as values that I obtain from that request object. So the data that's sent up here, the request object, I'm going to go and grab the values that I care about out of that request object and publish them into the parameters. I execute the SQL, and then I'm doing this is something a little unusual right here. Effectively, this little piece of code is looking for the employee number or the unique ID given to the record that I just created. So I'm basically calling in to select the generator from the interbase data table to say what's the number for that employee that we just created. And then I'm building a new JSON object containing that new record identifier and sending that back to the client. So let's go ahead and see this method function in the debugger. I'm going to switch to the post method here, and I actually need to set a content type as application JSON for this method because we're going to be pushing up a JSON body. And let me see if I have the JSON body that I prepared earlier. Okay, here it is. I'm going to make sure that you can read all of that request. Let's see if I can zoom in on it for you. Okay, and the reason that I want you to see this is there are some constraints on the database table. So if you're trying to replicate my results with my source code, you'll need to use the same or similar values to avoid hitting those constraints. Effectively, there are certain departments, and within those departments there are particular job codes and salaries, I believe. So you do need to pass in valid values. Now I'm passing in my name, first name Craig, last name Chapman, my phone extension, hire date, department number. I'm the vice president apparently, and I'm earning quite a large salary. So I'm going to go ahead and send that post in, but I need to make sure that I don't still have this item identifier. Okay, send request. And what I get back is employee number 155. So we've just created a new employee record for me, and the identifier for it is 155. So let's go back to our get method. See our employees, add 155, and let's send that request. And I can see here employee number 155, and there is the record that I just created. If I take off this identifier and request all records, then I'll still get all of the records, and if I scroll all the way down to the bottom, there's my new record. Okay, so that is putting a new record into a database using a REST call. Let's take a look at updating that record. Let's say I want to change my name from Craig Chapman to, I don't know, let's say I get married and I take my wife's name, Craig Jolie. So what we'll do here is we'll set our request to put translating to CRUD update. I'm going to keep the data in here because I'm going to be resetting all of these fields. I'm just going to change the surname here, And then if I come over to parameters, I want to make sure that I specify 155. So that's the record I want to update, 155, and I'm going to change my surname. So send request, and I get back 155 again, which is just a confirmation telling me this record has been modified. So let's go ahead and do another get, and we're going to select all records. And if I scroll right to the bottom of our data set, there is a happy Craig Jolie. Okay, so let's take a look at the last method that we want to look at, which is the delete item method. I'm going to go ahead and scroll down here. Now again, we don't want to delete the entire collection. We only really want to delete a single item. So we're going to pass up an item ID on the URL. I'm going to grab that right here from the request and convert that into an integer and store it as my employee number. So that's the employee that I want to delete. I'm then going to create a custom SQL statement to delete from the employee table where employee number is and parameterize that item number. And then I'm going to set the item number against that parameter and execute the SQL. And as a confirmation, I'm going to send the employee number back as a JSON object. So let's go ahead and execute the deletion of employee 155. So I need to add that to my URL. And I'm going to change the request to delete and send request. So it comes back with 155, and now if I go to my get method here and over to my parameters, I'm going to select all, send request, scroll right down to the bottom, and employee 145 is now the last employee in the database, so we've successfully deleted that record. Okay, so that's our 4 CRUD methods implemented on the server. What do we do for a client implementation? Well, I'm going to start by running the server in the background here. So I'm going to select run without debugging, and that's going to mean that my development server with our REST API is sitting running on it. So I'm going to move that off to the side, and we'll come into the employees client. Now this is employees client D for the Delphi source code, so we're looking at the Delphi version here. Now on my main form, I have all of the fields that we're pulling back from the database, and then I have these buttons. So read is going to read all data from the database. Previous will take us to the previous record, next to the next record, first to the first, last to the last. Then create will initiate the create mode. It's not actually going to make a REST call at this point, it's just going to set the form into a mode that can be used to create new records. And that's going to enable the commit button. So once we've entered our new record, commit will actually make the REST call and submit that record. Edit here is going to enter edit mode in the same way as create enters create mode. It'll allow us to edit the fields of a record, and once we're done, we'll be able to click update to send those updates up. And the delete button is going to allow us to delete an employee, whichever employee we're looking at. Now, the create and edit buttons, or rather the commit and the update buttons, when I click on those, what's going to happen is the REST call will be executed, and then it's going to automatically internally re-execute the read method to get all of the records again. This is of course inefficient. We should really just get the one record that we care about, but in the interest of simplicity for the source code, I just decided to recall that button. So let's take a look at the read button. What we're doing here is we're creating a REST request, and we're saying the resource I care about is the employee's resource. Then I'm setting the method, the HTTP method that I'm going to use, and this is read, so I'm going to use the get method. And then I'm setting the response component to receive the data back from that request. Now, the request and response components here are TREST request and TREST response. They're placed right there on my form. So I've placed them there from the tool palette, and I'm making changes to them in the code. The other REST component here is the REST client. Essentially, the REST client represents your HTTP client. So what you do is you set the base URL for the REST client to your server. In my case, this is the loopback address on port 8080. And then you set the request with the resource that you care about, employees, and you also point its response property at a response component to receive the data back from the server. Now, if I look at the content here on the response, there's none in it. If I right click and hit execute, I get a 200 OK. So I've executed that request for the employees data, and now if I look at my response, the content contains all of our employee records. So I've just used those visual components to create a connection to the service, and then within the code I'm modifying the parameters of those to make sure that I have the correct resource, the correct HTTP method, and I'm bound to the correct response. I execute the request, and then I'm going to decode the response that I get from the request. Now remember, this is a JSON array containing all of the employee records for the read method. So I'm going to decode all of those into a JSON array, which is actually at global scope within my class. So if I go and take a look up here, where did I stash it? There it is. So I'm basically putting this in as a private member of my class. That's going to contain all of the data that we get back when we read from the database. And then I have this method JSON to form, which is just going to copy the values. Let's go take a quick look. It's looping through that array, and it's just copying the values from that array to the various edit controls on the form. Now you could of course use live bindings to bind the data to the controls. This is copied from some older sample code that I had, and I just decided to do it this manual way for that case. So now we're able to read data from our service. Let's take a look at this application running. Okay, so if I hit the read button, it's going to pull back the records from the database. I can hit next, next, next and scroll through the data. I can hit previous to scroll backwards. I can go back to the first record, or I can skip all the way to the last record. Now let's try creating a new entry. I'm going to pass in Craig Chapman, phone extension 250, department number 600. I'm the vice president with a job grade of 2. I'm in the USA, and my salary is 105,900. When I click on the commit button, it effectively resets us back to employee number 2. But if I click the last button, you'll see that the new record, Craig Chapman, is in there. So let's go ahead now and edit that record. I'm going to click on the edit button, and again I'm going to marry myself off to a wonderful woman there and hit the update button. And when I hit on last, there is the updated record. And finally, of course, we can delete. And if I hit on last, I'm gone from the database. So let's take a look now at the commit method. So effectively, what's happening is when I hit the create button, the relevant controls are just being cleared and made editable. And so then when I hit the commit button, that's when I'm making my request. Again, I'm setting the resource, so I want the employee's resource. The method in this case is post, because I'm creating a new record. And then I'm going to clear out the body of the request, and I'm going to start pushing in as JSON data all of the parameters that I want from my form. So I'm pushing these in as property name, property value, property name, property value to write into a JSON writer. Then I am going to adjust the form for browse mode so that once we have executed the request, we're going to be able to read the data again. It's going to be read only. And then I just run the read button click again, so it's going to reread the data from the database. Very similar, the edit method here, if I go and look at the update button, I'm doing the same thing, but I am selecting a specific employee here. So I'm just modifying the resource that I care about with the employee number, which is taken from the spin edit on the form. And from there on, the code is almost identical. It's just going to do the exact same thing. And then finally, I should say almost identical, it's also using the put method. But otherwise it's going to do the same thing. And then finally, the delete method, again, I am adding this spin edit value to my employee's resource and executing the request and then rereading the data back. And again, this time I'm using the HTTP delete method to make that happen. So that's how to build REST services and REST clients using RAD Server and RAD Studio. All of the source code for the projects in the video today will be linked in the video description or in the blog post which accompanies this video. My name's Craig Chapman, and thanks for watching.